In this video, I'm going to show you how to solve a rational equation using cross multiplication. So here's our first problem. We want to solve 2 over x equals 6 over 7. First note that when solving rational equations, we often multiply and divide with variables. And as a result, we can sometimes get solutions that are invalid, because they cause a denominator of a fraction in the original equation to be 0. So, looking at this original equation, 2 over x equals 6 over 7, our solution cannot make any denominator 0. So, in other words, since x is in the denominator here, we need x to be not equal to 0. So, once we solve for x, we'll just have to check to make sure that solution is not 0. Alright, so without further ado, let's go ahead and actually solve this equation. What makes this equation a bit challenging is that there's denominators, and we want to get rid of those denominators. So what we can do is we can just multiply both sides by these denominators to cancel them out. So let's go ahead and write our equation again. 2 over x equals 6 over 7, and then we'll multiply both sides by x and by 7, because x and 7 are in the denominators. Now on the left-hand side, this times x will cancel out with that x in the denominator, leaving us just with 7 times 2. Then on the right-hand side, the times 7 will cancel with that divided by 7 in the denominator. So we'll be left with just 6 times x. And whoa, that's neat! The resulting equation just amounts to a cross multiplication. On the right-hand side, 7 times 2, that's just the product of the left numerator and the right denominator. Then on the right-hand side, 6 times x, that's just the product of the right numerator and the left denominator. So going forward, we'll just think about it that way. But for right now, we still need to solve this equation. Let's go ahead and simplify. 7 times 2 is 14, so 14 is equal to 6x. To cancel out that 6 on the x, we can just divide by 6 on both sides. That cancels. So x is just equal to 14 over 6, and we can simplify that fraction, 14 over 6. Numerator and denominator are both even, so divide it by 2. 14 divided by 2 is 7, and then 6 divided by 2 is 3. So x is equal to 7/3. Let's flip that around for clarity. X is equal to 7/3. And 7/3 is not equal to 0, so that's good. This is indeed a valid solution. Alright, so let's go ahead and solve this next equation. 8 over 3 equals 5 over y. First of all, let's check for any values of y that would make a denominator of 0 in the original equation. Y itself is the denominator here, so a value y equals 0 would make a denominator of 0. That would be an issue, so we need y is not equal to 0. Alright, so now let's go ahead and solve this equation. We know from the previous example that we can obtain an equivalent equation but without any fractions by using cross multiplication. So let's go ahead and do that here. So cross multiplication, we take the left numerator and the right denominator, multiply those, so 8 times y, that is equal to the right numerator times the left denominator, 5 times 3. So simplifying, this equation becomes 8y equals 15. And then to solve for y, we just need to get rid of that 8 that's multiplying it, and we can do that by dividing. Divide both sides by 8. That'll cancel out the 8 that's multiplying the y, and we just get y equals 15 over 8. And 15 and 8 have no common factors other than 1, so that's as simple as the fraction gets. We also see that this fraction 15 over 8 is indeed not equal to 0, so this is a valid solution. So that's it. There we go, we've got it. Y equals 15 over 8. Here's another problem. We want to solve this rational equation 2 over a plus 1 is equal to 3 over 2a. Remember, the first step is to figure out what values of a would make a denominator 0 in the original equation. So looking at this left denominator here, a plus 1, we need a plus 1 to be not equal to 0. We can treat this almost like an equation itself, Subtract 1 from both sides to get a alone. A is not equal to -1. We can also double check that. A value of -1 for a, if a were -1, that would make this denominator -1 plus 1, which would be 0. So yes, that is indeed a bad value for a. And let's find the other bad value. The other bad value comes from the other denominator, 2a. So we need 2a to be not equal to 0. Divide both sides of this by 2. You get a is not equal to 0. And indeed, if a were 0, that would cause this denominator to become 2 times 0, which is 0. Okay, so we know that a is definitely not equal to -1, and it's definitely not equal to 0. But what is the actual value of a? Let's solve this equation to find out. Again, we'll just use cross multiplication. It's a very convenient method to manipulate these kinds of equations. So take the left numerator and the right denominator, multiply them. So 2 times 2a is equal to the opposite cross, the right numerator times the left denominator. So 3 times a plus 1. Now this is a nice linear equation that we can solve. Let's start by simplifying it. 2 times 2 is 4, so left-hand side is just 4a. And on the right-hand side, we'll distribute this 3 over the sum a plus 1. 3 times a makes 3a, and then plus 3 times 1, which is 3. Now to solve for a, we can just move a over to the left-hand side. So let's go ahead and subtract off 3a from both sides. And the result, 4a minus 3a, well, that's just 1a, or just a. And then on the right-hand side, this 3a minus 3a, that cancels out, and all we've got left is that plus 3, so just 3. So there we go, a is 3. Indeed, 3 is not equal to -1. It's not equal to 0, so it is a good solution. It is a valid solution, and that is it. We are done. A equals 3. So now we know how to use cross multiplication to solve rational equations. It's a very convenient method which arises from just multiplying the equation by each denominator on each side.